Imagine a computer so powerful that it can solve problems that would take today's most advanced supercomputers millions of years in mere seconds. Welcome to the world of quantum computing. This is not a scene from a science fiction movie, but the dawn of a new digital revolution that's changing the way we understand and interact with the universe. Quantum computing, at its core, is a radical departure from the classical computing we've grown accustomed to. While classical computers operate on binary bits, that is zeros or ones, quantum computers leverage the peculiar properties of quantum bits, or qubits. These qubits can exist in multiple states at once, thanks to a quantum phenomenon known as superposition. This enables quantum computers to process an astronomical amount of data simultaneously, providing unprecedented computational power. But it's not just about raw power. Quantum computing brings a new dimension to problem solving. It exploits another quantum property called entanglement, where the state of one qubit instantly influences another, no matter the distance. This interconnectedness brings a new level of sophistication to tasks such as optimization and modeling, making it an ideal tool for industries that require complex computational modeling and data analysis. Picture a pharmaceutical company designing a new drug. The quantum computer could analyze and model countless molecular interactions in a fraction of the time it would take traditional computers. Or consider logistics companies, optimizing routes and schedules for thousands of deliveries in real time. Even industries like finance could benefit from quantum computing's ability to model and predict complex market behaviors with unparalleled accuracy. The potential impact of quantum computing is vast and far-reaching. It is poised to revolutionize fields as diverse as cryptography, climate modeling, artificial intelligence, and beyond. It's an exciting time to be at the forefront of such a transformative technology. Quantum computing isn't just a concept anymore, it's a reality, and it's about to revolutionize industries. At the heart of quantum computing lies the McGinty equation, a mathematical expression that might seem complicated, but let's break it down. The McGinty equation, or MEQ as we'll call it, is essentially a way to understand the behavior of quantum systems. It's like a recipe, guiding us on how to mix different ingredients to get the desired outcome. The first ingredient in our recipe is psqft-xxt. Now don't be put off by the Greek letters and parentheses. Simply put, psqft-xxt is the solution of the free quantum field theory. If you're thinking, wait, what's a quantum field theory? Don't worry. Just imagine it's a fancy way of saying how particles in a quantum system interact with each other. It's like trying to figure out the dance steps in a choreographed performance, where each dancer is a particle in our quantum system. The second ingredient in our MEQ is fractal XTDMQS, the fractal potential term. Now, fractals are patterns that repeat at every scale. If you've ever seen a snowflake up close or the branching pattern of a tree, you've seen a fractal. In the context of the MEQ, this fractal potential term describes how quantum systems have similar patterns repeating at different scales. But the MEQ isn't just about these two components. There's also a modified version of the equation that includes an additional term, psgravity XTG. This term represents the effects of gravity on the quantum field, kind of like how gravity influences how an apple falls from a tree. In the quantum world, though, gravity's impact isn't as straightforward, and that's why we have this extra term in our equation. So think of the MEQ like a roadmap. It gives us a route to follow in understanding the intricate dance of quantum systems. It tells us how particles interact, how patterns repeat across scales, and even how gravity makes its presence felt in the quantum realm. So the McGinty equation, while complex, is essentially a roadmap to understanding the behavior of quantum systems. Like any good theory, the McGinty equation has evolved over time with modifications to account for additional factors. One such modification is the inclusion of scgravity, XTG, a term that represents the effects of gravity on the quantum field. This term is accompanied by a parameter g, which characterizes the strength of the gravitational force. The role of gravity, often overlooked in quantum theories, is thus given its rightful place in this equation. But the modifications don't stop there. When we combine the modified McGinty equation with general relativity, we get a more comprehensive picture of the behavior of quantum systems. This combination allows us to delve deeper into the quantum realm, exploring phenomena that were previously out of reach. These modifications to the McGinty equation, therefore, are not just mathematical tweaks. They provide us with a more robust and adaptable tool to probe the intricate mysteries of the quantum world. These modifications to the McGinty equation allow us to account for even more phenomena in the quantum realm. Now that we understand the math behind it, let's see how MEQ Quantum Computing Services is using this knowledge to create high-value solutions for various industries. MEQ Quantum Computing Services is at the forefront of a technological revolution, leveraging the power of quantum computing to offer a new breed of computational services. One of the key offerings is quantum computing as a service. This innovative service model allows businesses to tap into the power of quantum computing without the need for massive capital investments in infrastructure and expertise. But what does quantum computing as a service really mean for industries? Well, picture industries that require complex computational modeling, optimization, and data analysis. Think aerospace, pharmaceuticals, logistics, energy, and finance sectors. These industries often grapple with problems that traditional computing paradigms struggle to solve efficiently. Enter MEQ Quantum Computing Services. By harnessing the power of quantum computing, MEQ is enabling these industries to solve complex problems faster and more accurately than ever before. For instance, in aerospace, quantum computing can optimize flight paths to minimize fuel consumption and reduce emissions. In the pharmaceutical sector, it can expedite drug discovery by modeling complex molecular interactions. In logistics, it can optimize supply chain operations, and in finance, it can model complex financial systems to mitigate risks. The potential of MEQ's services extends beyond just these examples. Quantum computing is set to revolutionize how we approach problem solving across a multitude of sectors, and MEQ, through its quantum computing as a service, is positioning itself as a catalyst in this revolution, empowering industries to push the boundaries of what's possible. The impact of MEQ Quantum Computing Services is not just limited to business and industry. It's reshaping the very landscape of computational science, paving the way for a future where quantum computing is a standard tool in our problem-solving arsenal. With the power of quantum computing harnessed through MEQ services, the possibilities for industry innovation and growth are truly limitless.